but I would like to have the interactive part during our Q&A session. So until then, I would like to please everybody shut down your microphones and also shut down your cameras. You will be given the opportunity to participate and have your questions answered, but up to now, also to improve quality, it would be great if you would not use your camera and also not use your mic. As maybe some of you know, we will be voting on the proposal of the climate law in European Parliament in the plenary week next week. The Green Deal, the State of the Union address, and also the Commission climate targets are now known. And whereas Ms. von der Leyen had started out with increasing the climate ambition of the European Union to 50 to 55%, which should be determined in an impact assessment, now the Commission has come out last week saying, okay, it will be at least 55%, but we still have not yet secured a Parliament's position on that. There has been a vote in the Environmental Committee on the report by our rapporteur Jutta Guteland, who is a colleague of Timo in his group, and the ENVI committee has voted on a 60% reduction. My own group, the Green Group, has said, well, the scientists tell us that in order to achieve the climate goals of Paris Agreement, which would be well below 2 degrees, if possible 1.5 degree, we would need a 65% reduction until 2030. So this is the goal that we are striving for, but we will have to see where we can secure a majority. And the wonderful thing is that there are actually tools where you can model how is this target to be achieved. We have to be ambitious. We know that. We had the special report by the IPCC showing us that even if we achieve to keep global warming at 1.5 degrees, we will lose 70% of our coral reefs. And if warming accelerates to 2 degrees Celsius, we will lose 99% of our coral reefs. And as you might know, coral reefs are responsible for more than 25% of all life in ocean, because a lot of fish and also mollusks have their babies, so to speak, grow up there. So it's not just a matter of 0.5 degrees Celsius, it is really a matter of ecosystems surviving. It is not even that difficult to achieve this climate target of 60 or 65% by 2030 because the solutions are there. We have incredibly cheap, ridiculously cheap, as Bloomberg puts it, clean solar and wind energy, which outperforms fossil fuels even today. It's cheaper to harvest solar and wind energy than to build a new coal power firing plant. So we have to ramp up our ambition. We have to make it possible that citizens take part in the energy transition, because a lot of people I am talking to say we are afraid of the world that our children will grow up in with a runaway climate change, maybe. So they want to act, they want to do something, they want to be part of it. And I think we should unleash this potential of citizens' energy, which has already been made possible on EU level by the legislation in the last mandate. And now we have to translate it into national law. And this is going to be a huge task because a lot of member states are rather reluctant in enabling their citizens to be part of the energy system. And let's not forget our wonderful researchers. I read an article just this morning on alternatives to using limestone for producing cement. And this alternative with clay would actually save up to 50% of CO2 emissions. And as the cement sector is responsible for 7% of global emissions, you can easily imagine what a shift there could enable. I'm looking very much forward to the climate study, the climate tool, and the fruitful discussion. And I would now like to give the word to my wonderful colleague Timo, who is also a climate champion in his group. Timo, thanks for being here with us. Thanks for taking part in this discussion. It was it was a pleasure to organize this together with you and your team. You have the floor.
Thank you very much, Jutta, for the very nice words. And welcome from my side also to all to this webinar. So sorry that I was not looking directly into the camera, but I was just tweeting about our seminar and inviting even more people and sharing it in my stories. So sorry for that. So we will have a timely debate about the 2030 emissions reduction target today. And as Jutta already said, just ahead of the vote next week. And I also want to extend my thanks to Climect for co-hosting this event and for presenting their report. We will talk about models to reach 65 and 55% greenhouse gas emission reduction today. And next week, we will vote on ambition levels of 60% and also 65%. We want to demonstrate in this webinar that we can reach significantly higher goals as the 55%, including things that the Commission proposed a few weeks ago. And I already undertook the simulation with the tool you will see today myself. And I would like to thank you for this very useful and open source database. It's very interesting to model your own climate change path or climate change fighting path. As we are already discussing simulation of 55 and 65% in the report from Climate, my assistant Charlie and we took the shared effort scenario and pulled it in some sectors. Like this, I reached 65% with LULUCF and 57% without LULUCF. And this shows that we have many solutions that we can unfold already towards 2030. And some of the main features I choose in this scenario are: road vehicle sales are decarbonized in 2040, including heavy duty vehicles. So steel decarbonization offers a lot of opportunities, and the manufacturers themselves want to get on the way. If there is public support, a decarbonization by 2035 is feasible, I think, and renewables development should focus on wind and solar, less on bioenergy, and we should not rely on, and we should not rely on CCS. So in my model, I included full deployment of renewables by 2045. So with the Renovate Europe initiative, I think we will set in motion a big renovation wave, which offers also huge potentials. So I turned up the renovation of commercial buildings a bit. So much in this short time about the technologies. I think we will discuss that in more details later. And after the vote next week, we can talk about political implementations. This will be a matter of tough negotiations, of course. Some priorities I would already like to mention very shortly. First, the ETS. Yes, the ETS is the most effective short-term tool we have. We definitely need to strengthen it, as we have still huge surpluses of allowances. This can be very effective in setting price signals toward electricity markets, especially. I think we should also set a minimum price as a political signal. Second, effort sharing. This is also a very important tool, and we should not undermine it. Let's not forget that this is the actual legislation that set many member states in motion. We need them on board if we want to decarbonize all sectors, but also, this needs to be said, there are political actors who do not want to touch the effort sharing because they think this is opening the box of Pandora. And lastly, this is very plain, we need renewable energy. We need to use any lever to build and use renewables as much as we can. This is, I think, the biggest job motor we have for the recovery. So I'll share with you our model. I'll just put it in the chat and I'm happy to discuss this, but I'm now looking very much forward to the presentation and especially to the discussion after that. Thanks again for being here and enjoy the presentation.
Thanks very, very much. And thanks for telling us that you are using this tool, because this is in the end the objective of such tool. So let me share my screen. I hope everybody can hear me well. So we are from Climact. Let me just display this. Climact is a Belgian consultancy. We are working to support private and public decision makers to effectively reduce the greenhouse gas emissions in line with the Paris Agreement. And one of our tasks with the NGOs and public bodies is to develop scenarios, long-term scenarios or short-term scenarios, to see what are the options to be in line with science and the Paris Agreement. And so today we are very happy, my colleague Julien and I, to present you some of the findings of one of our studies we did at the European level. So basically today we will show you a transparent model, the transparent model that Timo just mentioned, which allows the user to play and test options to reduce the greenhouse gas emissions of the EU 27. Thanks to the model, we have developed a set of scenarios and a report that shows that it is technically feasible to achieve 55% or even 65% reduction of the greenhouse gas emissions by 2030 compared to 1990 level, when excluding the LULUCF. And so you can do it also when including LULUCF, of course. But that remains a challenge, and all the sectors need to contribute. And we will show you what are the key learnings we have identified thanks to our modeling exercise. So basically, our initial objective was to show how the EU can raise its current target and what it means in terms of concrete and tangible implications. More recently, we have been using that tool and these scenarios as well to discuss the EU Commission impact assessment that was published a few weeks ago. So we will try today to, as a sneak preview, to share with you also some of the learnings from that comparison. So just in terms of scope, so we are looking at emission reduction compared to 1990. The initial model was, or the initial report on 2030 was excluding the LULUCF to be in line with the current target. But obviously, LULUCF needs to be considered because it plays a massive role in reaching carbon neutrality by 2050, and also because the European Commission has suggested to include it in the discussion. So there are two reports where you will find more details about what we're gonna present today. One report on a discussion on 2030 targets. This is the main topic today. And more recently, another report published just this Tuesday or Monday, discussing the impact assessment. It's all available on our website. Julien, I will give you the floor for presenting the tool.
Thank you, Jérôme. And thanks everyone for joining. I have a bit of an echo here. Obviously it's quite challenging to present you the tool and the results in such a short time, but we'll try to give you a good flavor of what it does. I'm first going to give you, you want to keep sharing the presentation? So first of all, what are we basing ourselves on? We're leveraging the CTI model. It's a tool that's comprehensive and dynamic, and we cover all energy sectors and all greenhouse gas emissions. The tool has been built over multiple years, gathering insights from a lot of stakeholder engagements, expert consultations, and that's fed all of the assumptions that we're using in the model across the sectors. It's open source. It also has an online version, which Timo has already used, and that online version allows you to test new scenarios and really understand what the assumptions are that were used in the scenarios. So all of this is really there to develop energy transition scenarios based on realistic and transparent assumptions. It's not a model that does forecast. It's not short-term forecasting. It's really about longer-term, mid to long-term scenarios. It's also not cost optimizing. A lot of other tools like primes are leveraging cost optimization. We don't trust cost optimization for long-term scenario pathways, because we think that it can lead you to take avenues without being sure of what the cost reductions will be, and without really understanding what happens in the choices you make. It's also not a macroeconomic analysis. We are looking on the side of the model at the co-benefits and the impacts on the macroeconomy, but not within the tool itself. So that's just to give you a flavor of what the tool is. Next slide then, Jérôme. So when we're talking about a dynamic tool, this is what we mean. We're connecting the sectors together very strongly. So we start off from the demography, of course, the economy and so on, and the lifestyle assumptions. And these are important in the model, and they're often very much disregarded in other models, which do not manage to capture them as well. So lifestyle covers also the organization of society. We're looking at, for example, the travel demand, the mode and occupancy. I'll come back to mobility afterwards in the transport sector, but this is a very strong and important lever. So all of that feeds the sectors themselves, where we're looking at energy and climate and greenhouse gas emissions, and we're connecting the sectors between themselves. For example, transports, all of the assumptions you take there will impact the amount of manufacturing you'll need, the amount of steel or plastic that's required. So all of these connections are done in the model. Obviously, we also connect transport to land in the way that biofuels are used and are helpful to decarbonize transport. And of course, also to electricity production and the amount of electricity required. So this is the type of dynamics we cover in the model. And that also connects to imports and exports outside of the EU, which are of course important to connect all the dots. So we want to just quickly highlight the online tool. This is how it looks. Do you want to connect to the online tool then, Jérôme, or do you want to give me the screen?
I will give you the screen. That will be easier, I think.
Okay, great. So do you see my screen now with the tool?
It's coming.
So do you see it now?
Not yet.
Is it there now? Let me know when you have it. Yes, no?
No, we can see that you started the process, but it's black.
Could you maybe try to stop sharing and sharing again?
Do you see it now?
Yeah, it's okay.
Yeah.
Okay, great. So you see how the web tool, this is the conversion of the model I described into the online web tool. And you see how you have the output parameters here, all of the implications, and you can choose the implications that you look into here with the menus. And below, you make all of the assumptions on the sectors. So typically, I talked about transport. You can define the level of energy efficiency that you can reach, and you have that in a very simple way from scale to 0 to 3. 0 being no ambition at all, and 3 being the maximum ambition. And so you can define, well, for example, the online transport demands. Do we have an increase in transport demand for citizens across Europe by 24% between 2015 and 2050, or do we strive to shift behaviors and have a reduction in transport demand? Of course, that's the pure lifestyle lever, but you have other ones like the technology evolution, where you can look into the amount of electric vehicles that are being put on the roads over time, and do we reach by 2050 100% of sales in zero emissions vehicles? So these are the type of descriptions you have that help you clarify exactly the choices you make. And you also have a few scenarios that are predefined here that you can select that help you start from more or less ambition in the scenarios. So this is really how we're building the scenarios, and you have directly the key KPIs here on the right hand side that allow you to understand where you reach. We don't have enough time now to go deep into it, but Tiemo has shared the link. If you have any questions on the tool, don't hesitate to come back to us. And we hope that you'll be able to define some new scenarios and better understand the transition with the tool. What I suggest is that we now start moving to the key messages that we've extracted from the tool, and also deep dive into the sectors. Jérôme, you're.
Thank you, Julien. Let me take the hand back. So as Julien said, we thanks to the tool, we have defined different scenarios trying to reach, looking at the KPIs here on the right, to reach 55% reduction by 2030 or even 65% reduction. And we did it by playing with the different families of levers. As Julien said, some of the levers are more lifestyle oriented, some other levers are more technology oriented. And so we came up with 3 scenarios that you have here a direct link. And by the way, these slides will be made available on our website after the webinar. So by just clicking on these links, you will access these predefined scenarios. Obviously, there are other scenarios, and you can choose. And as Timo just introduced, you can push a little bit the things that you think are more relevant, and maybe lower the effort on some other aspects, some levers. So based on these 3 different types of 3 different scenarios, we came out with the conclusion that yes, it is possible to reach 55% or 65% reduction by 2030, excluding LULUCF. We have seen how also for 55%, there is some flexibility. We have managed to create a scenario which is putting more emphasis on technologies only and preserving our current lifestyle trends. And we have another scenarios called the balanced scenarios, where putting a bit more effort on the lifestyle changes and a bit less pressure on the technology development. We have also managed to create a 65% scenario, which means that a 65% scenario means that you need to activate the full range of levers pretty soon. There is a little bit less flexibility, obviously, given the short time frame that we are looking at. So we have different scenarios, even though the 55% scenarios look from a general perspective to reach the same target, they do it on a very different way. Looking just at, for instance, the amount of carbon capture and storage that is required in the 2 scenarios, you see that the balanced scenario only expects 7 million tons of CO2 capture by 2030, which is roughly speaking, I think, the commitment of the Netherlands, while the technology scenario requires more than tripling that amount of captured carbon by 2030. And you can see also for the transport sector how there is a significant difference between the 3 scenarios in terms of emission reduction. And when you play with such a tool and when you try to reach your target, you will quickly observe that there are very strong relationships between the sectors. And if you lower the effort somewhere, you need to push much harder on some other sectors, which is the key interest of this tool. And so in terms of cross-sectorial links, the key things that we have observed are the following. First, the power sector has a major role because it helps decarbonizing other sectors. This is why in our 3 scenarios, the power sector is reaching 90% reduction of its emissions by 2030, irrespective of the scenarios. Next, from the industry plays a major role in providing the materials that you need to develop the technologies, to deploy the technologies for other sectors. Like think about renewables, for instance, you need a lot of materials, or electric vehicles, you need materials as well. So the role of decarbonizing the industry is central as well to help the other sectors and the overall emissions to be reduced. So shifting to a more circular and functional economy is a key conclusion of this study. Bioenergy is sometimes used to decarbonize other sectors when some technologies are not yet available. Think about transport or heating the buildings. But obviously there are limitations to the way we can use bioenergy, limitations in terms of sustainable potential, and also limitations in terms of conflicts with other land uses, which could contribute to carbon capture, for instance. And then more generally, there is a kind of trade-off to be found between technology development, which helps preserving the economic activity, doesn't ask us to change our lifestyle very much, but may raise some other challenges in terms of resources availability, in terms of investments, and so on and so on. And then there's the question of the timing. When you play with the tool, you will see that that 2030 is very soon, and that also is a key milestone towards 2050. So any effort that you don't do before 2030 will need to be done shortly after 2030 if we want to reach net zero emissions by 2050. So as a conclusion, all these scenarios require very urgent and strong actions from in all the sectors. So now we will dive into each sector separately. We have many conclusions. We will try to focus on a few highlights, and you're welcome to come back with sectorial questions after our presentation. Julien, this is for you.
So transport, it's already one of the sectors where you can see very stark differences between the two scenarios, and actually the three scenarios with the 65%. And the question is really how we see mobility in the future. Do we encourage a new way of looking at mobility in Europe? Do we want to ensure cities that are built to allow for softer modes like bikes and electric bikes? You know that currently privately owned vehicles are sitting idle 95% of the time. So that's a massive waste of resources. Do we want to push a better use of that resource? Do we want to also ensure that those vehicles are being built to last much longer? So all of these questions are really key to the contrast that you'll see in the scenarios. Maybe then the next slide. You see here on the next slides the evolution of the vehicle fleet, and you really see the contrast that I was talking about with all of these trends. Do we go into a more technology-focused scenario? You see the 55%, the first column for the 2030 scenarios, which roughly stabilizes the fleet of vehicles, but looks at a very strong shift towards electric vehicles, the green part on top. And that's already about 70 million vehicles on the road, so electric vehicles on the road by 2030. So that's one scenario. The more balanced shared effort scenario is looking at pushing all of the levers concerning modal shifts, the shared mobility as a service already much faster, and also in a way trying to capture the added value for the industry through improved transport and improved mobility. And so you see that in that case, the fleet reduces significantly, because as people start owning cars less and using shared fleets, obviously the cars are being used more and the fleet is smaller. So and then in that case, you see that the amount of electric vehicles required is much smaller. You can reach 55% by mostly having a better use of the vehicles and starting the shift towards electric vehicles, but not going as quickly as you need for the technology focused scenario. And then you have the 65 scenario, where clearly, as Jerome was saying earlier, everything needs to be done. So you need to do both a strong reduction in the fleet by leveraging the demand side levers, but also quite a significant amount of shift towards electric vehicles. You see that the green box, the amount of electric vehicles is already bigger than the balance scenario. So that's in a nutshell really the contrast between the scenarios, and really none of them are simple. We find that going for the technology focus will be very challenging. And obviously shifting the societal organization of transport, the way we look at mobility is also very challenging. Here you see that what it means in terms of energy demand. So there's strong reductions in both the 55% to around 30% less energy used. So that's a relatively similar figure, but as you can see, and as you saw in the previous slides, the mix behind that is very different. And for the 65%, as we're pushing all of it faster, we get to a 55% reduction in energy demand. So that's very quickly on some of the key results for transports. If we then move to buildings. So in buildings, the key there, as most of you know, is around how fast and how deep we renovate and how much we decarbonize the heat that we still need. What we find is that we really need to double or triple the renovation, and we need to do that at a depth. And that's a very important factor that not everyone talks about when talking about renovation. We really need to do that at a depth that is at a minimum an average of factor 4. So reaching around 75% energy consumption after renovation. If you don't do that, the heating sides will be extremely hard to decarbonize because you're effectively trying to use heat pumps, for example, in houses that are not renovated, which means that the coefficient of performance of these heat pumps is very bad. Or alternatively, you try to shift to biomass, but there isn't enough biomass to use in all of the houses if you need to share the biomass potential across the sectors. So really very strongly, we need a focus on renovation and the depth of renovation. That will attract good and strong co-benefits, but we think that it requires really innovation on the building sector, which is still too much relying on old ways of renovating, and we need to digitalize and industrialize the refurbishment of houses to really make that attractive at a large scale. So then next slide. You see here how that converts into renovation for the building stock. So this is the amount of square meters of the whole building stock across Europe. And you see the difference between the two 55% scenarios on the left and the fact that the techno-oriented scenario doesn't reach full renovation by 2050. It's only reaching about 70% of the stock, while the 55 balanced and the 65% increase the renovation rate and reach the full stock by slightly earlier than 2050. So that's really the strongest difference, which means that the techno-oriented scenario is more focused also on than the depth, which is technically more difficult because you need to more innovate and industrialize. So there's more focus on pushing that industrialization of the buildings, of the renovation of the buildings, so that we can reach very strong depth of renovation quickly. That's the contrast between the scenarios. And we've looked then at, so you see here the greenhouse gas emissions covering all of the buildings from 2015 and then to 2030 for the range of the scenarios that we talk about in the CTI, the 55% ones, and the one from the impact assessment from the Commission that was just released. You see the range for the three main scenarios reaching 55%, careful, 55, including LULUCF. And you see that actually the ambition in the impact assessment is very strong. It's very good. We're very impressed by the ambition they have. And they're actually going to double the amount of reductions in greenhouse gas emissions. And we'll come back when we talk about power on what that means for the other sectors. So very strong ambition in the impact assessment. But if we go to the next slide, you'll see that it's quite strongly related to the fuel shift. So they really rely very strongly on taking out coal and oil from the building sector, which means they have a very, very strong fuel shift required and a very fast one. We find that potentially they're missing a little bit of ambition in terms of the renovation rate because they don't reach the 3% that we have in the shared effort scenario. So they're clearly more focused on the technology focused scenario that we highlighted in our report, but still very strong and very good ambition from the impact assessment. I think that was it for buildings. Jérôme, I'll give you the word for industry.
Okay, sorry. Here we go. So for the industry, you remember that the industry is taking as an input all the resulting activity from the transport, from the buildings, and from the other sectors. So it's looking at how many products we want to manufacture in the EU, and then there are some industry-specific action levers, like changing the way we design our products, the type of materials we use, the share of recycled materials we use for the products, also the lifetime of the assets, and so on and so on. And based on that, we have seen that there are different scenarios for the industry again, but there is a clear need to shift from today's production principles to a much more circular and functional economy. Circular economy meaning basically that we have, through a better design and a better use of the materials and more recycled materials, we need less resources at the beginning, and we need to manufacture less raw materials. A functional economy is an economy where you use the assets rather than buying them, you rent them. I think mobility as a service, for instance, which allows extending the lifetime of the assets. And all these have actually lots of co-benefits for the EU in terms of added value of the product, in terms of job for the maintenance, and so on and so on. So basically, looking at our scenarios, we have seen how the technology scenario allows to keep today's production levels, or to limit the reduction of the production level. But this requires a lot of technologies behind, including some carbon capture and storage. The 55% and the balance and the 65% scenario are engaging into the circular economy and the functional economy much more quickly, well before 2030, and that limits the amount of carbon capture and storage that is required. And basically, the 55% balanced scenario has a 15 years transition time for the industry. If you look at the graph on the online tool, you will see that over 15 years, things are massively changing. For the 65%, that would mean 10 years in terms of transition period. So it's a question of accelerating and not only looking at additional action levers. These may have a lot of social impact. This is not easy to do. So it means that we need to find ways to support that the just transition of the industry and the other sectors in general. So looking at just one graph to illustrate the difference for the different industry subsectors, you see here the impact for the manufacturing of products for the 55% technology, the 55% balance and the 65%. So you see that in a technology scenario where we keep pretty high level of demand for products, we are not that aggressive on the lifetime of assets and so on. We reduce the manufacturing by 10% by 2030, which requires some other technologies behind to reduce the emissions. In a 55%, we increase the demand side actions, so reducing travel, reducing floor space, reducing diets, and so reducing fertilizers that are needed in the agriculture, and so on and so on. We activate some more levers on the functional economy by extending the lifetime of the assets, repairing rather than by producing new. We also activate the circular economy levers through better design, more recycled materials, and so on and so on. And that leads to a reduction of about a third of the current materials, with as a co-benefit many added value for the products, and also probably some jobs on the maintenance side of all these high value products. The 65% scenario goes even further by 2030. So the material production is reduced by 43% according to our modeling. So you see here again that there are contrasted options which all have pros and cons, but it is important to keep the total trade-offs in mind when designing the right policies. Now for the energy supply, that's for you, Julien, again.
Yeah, and just to add on to the industry side, I mean, you've seen the reductions in the manufacturing will clearly require a just transition mechanism to be put in place. There will not be, I mean, and all three scenarios have reductions. So that means some regions will be affected and will need to have support to do that. So now if we move to the power sector, Jérôme has already mentioned very early on in the presentation, we see very strong reductions in the power sector across all three scenarios. We need, there's no way to reach 55 and let alone 65 if you're not phasing out coal or close to a phase out. We're actually keeping a few terawatt hours of coal. And we need to move directly to renewables. There's also a reduction in gas in the scenarios to reach 90%. So that you need to be careful about minimizing the new investments in gas infrastructure to avoid making them stranded assets. How does that happen? There is all of the demand side that helps reduce the pressure. And we'll see in the next slide, Jérôme, how that converts into the amount of power required. So you see here how the three scenarios compare in terms of power demand in 2030. And this is compared to the 2020 amount. So the technology scenario with what happens on the demand sectors increases the amount of power required by 15% compared to the other two, which reach minus 10% compared to 2020. So that's the starkest contrast between the scenarios, and it's really actually coming from all of what happens on the demand side. So that increase in power demand means that there's a need to build out renewables faster and more massively in the technology scenario. You see that we need to triple the amount of renewables compared to 2020, reaching almost 2,000 terawatt hours. That compares to a bit more than doubling it in the 55% balance scenario and the 65%. So that's the strongest difference. For the rest, the phase out from coal is very similar in all three scenarios, very strong. And also a strong phase out from gas, although there is some gas left in the 55% technology scenario. If we compare that to the impact assessment that just came out, you see here again the two scenarios from the CTI model, the 55 shared efforts and technology focused, and you see that contrasted in the last column to the scenario from, or at least what we could infer from all of the text in the impact assessments of what it means. And so it's actually roughly in between in terms of the renewables deployment. You see it's at a more than doubling and between doubling and tripling the amount of renewables, the green block on the bottom. And this is because it's keeping about 15% of gas in the mix of power production. So the impact assessments in the three scenarios reaches the conclusion that they do a little bit less on power, which means they also need to do some more on the other sectors to reach 55%. And that's also what we've seen when we discussed the building sector. You've seen how ambitious the commission scenarios were in terms of greenhouse gas reductions in the building sector. So that's really then a trade-off not only between scenarios but between sectors to see whether more focus should be put on one and the other. We felt that it was easier to push with a centralized approach in power for faster reductions instead of having to push that across all of the building stock across Europe. So shifting the production here based on gas to alternatives is what comes out in our scenarios. So that was it on power.
Thanks. For agriculture, forestry, and land use, it's an interesting sector also because it reflects a lot of interactions between the different sectors. And also in terms of overall dynamic. You remember Julien said that the model is taking as an input our lifestyle, so also our diets. If you change the diets, if you change the amount of meat that we eat every day, it means that you have changes in the agricultural production. You have changes in the land use because you need less crops for growing feed, and you need maybe less grasslands. Then you have some surplus land which can be used to either to extensify the agricultural practices or to grow forest or permanent grasslands to develop carbon capture on a natural way. So here again, there are different trade-offs and different options for agriculture and forestry that are pretty clear in our scenarios. So on one hand, you can bet on more efficient agriculture, so precision farming, better use of the land, of the current crops, and so on and so on. Some more, let's say, technologies or new innovative measures to improve the feed of animals, and that will allow you to reduce the emissions without changing fundamentally the diets. But changing diets might be useful as well. First, because it is recommended by the World Health Organization, so which recommends to halve our meat consumption in average in the EU. And so in that sense, scenarios reducing the amount of meat or changing the type of meat are more aligned with health guidelines. And the land use, even though it was not part of the current target or in our previous study, is key also to develop the natural sequestration potential for absorbing CO2 from the atmosphere and contribute to the net zero emissions target by 2050. And playing with the land use, changing the type of land and the type of crops, the type of forest, has also an impact on the amount of residues that are available for sustainable bioenergy in the end. So that has, as a loop back effect, an impact on the other sectors. So our three scenarios are slightly different in terms of diet plans. So the technology is basically following the current trends, which is reducing. No, it's actually 11% reduction of the meat compared to today's level, while the trend would be 5%. If I'm not wrong, the impact assessment from the Commission is just relying on the current trends without activating any lever on that side. So it would be close to the meat quantity trend you see on the left-hand side. You see that the 65% is going up to 32% reduction of the meat consumption, and also a shift from ruminant meat to non-ruminant meat, which in the end is closer to the World Health Organization guidelines for this. So this has impact on the amount of forest, of grassland, but also in terms of residues that is available for bioenergy. You see here a comparison of our scenarios, the technology in the balance scenarios compared to the impact assessment scenarios. Basically, in terms of solid and gaseous biomass, there is no big difference between our two sets of scenarios. You see that we are pretty close to today's level. But in terms of liquid biofuels, so the biofuels for transport mainly, there is a significant difference. So while our CTI scenarios are reducing the amount of liquid biofuel compared to today's level by 15% approximately, you see that the Commission is almost doubling the amount of liquid biofuel that in the suggested scenarios. So this is the key difference. That leads us to the cost. Obviously, when you have a more technology-oriented scenario, you need more investment in these technologies. So you need more capital investment. You see here the dark blue box. These investment in efficiency and in new processes, in new technologies, allows you to reduce the amount of fuels that you use. You obviously need also some operational and maintenance costs that are associated to these new technologies, assets, and so on. In the more balanced scenarios, or in the 65% scenarios, you need less technologies thanks to the demand side actions. And you see that as a consequence, the amount of capital investment is reduced. It's not so far from today's level, from a business as usual level. And the fuel costs are massively reduced, and so are the OPEX as well. So obviously, the scope of the cost should be very carefully analyzed, but we have similar conclusions in other scenarios from the Commission, where you see that if you reduce the demand side, that you activate the demand side actions, in the end you have scenarios which have less investment costs. So this is all for the quick presentation. I know that time is flying.
Indeed.
So I give you the word back for our Q&A session.
Yeah, thank you very much. I was just about to ask you to finish, but this was then the perfect timing. Thank you very much for this very interesting, very comprehensive overview. In the meantime, I realized that I, in the beginning, shared the wrong simulation with you, but you now have the link, and all of you can simulate their own way to a low carbon emission society. As this is not only a presentation but also a discussion, I would now like to encourage all of you to take part in the discussion, to raise your questions, to let us know what you think would be necessary, or especially if you have any questions around the model which is used. And I would like to open the floor. You can raise your questions via the chat, or as we are in an interactive web session, you can of course also come in and ask your question orally and share your video if you want. And I just ask if someone is ready to start with the first question. And we all know the first one is always the most trickiest one and the most hardest one. But
I might just make a start. I was a bit wondering on the power sector, where we saw on the slides that there still is a considerable amount of nuclear power in the scenario, and I was wondering, where is this nuclear power going to come from? We have not only Germany, but also Belgium, Spain, and so forth, who have already committed to phasing out nuclear. The only 2 nuclear reactors that are being built and have been doing so for 10 years now are in Finland and France, and both projects are much overdue in time and in cost. And the only countries I know that are actually planning to build new nuclear reactors beside those 2 is Poland and Czech Republic, and they have very high problems finding financing. So my question would be, what were the assumptions behind that pretty large share of nuclear? Thank you.
So this is directly coming from the announcements that were made at the time from the various countries. So indeed, some have made announcements and are running into issues, more issues than they were thinking they would. But by 2030, there is still a large part of the fleet which will be around. So it's taking into account the end of life and the announcements that were made. Clearly, though, after 2030, as we start, coming to the end of the lifetime of more of these assets, of more of these power plants, there will be a need to continue implementing alternatives over time. But we actually have quite a similar number as the nuclear amounts in the Commission scenarios, which is following the same logic. They've done that, of course, a bit later, and it's interesting to see that about 50 to 70 terawatt hours lower. So which would go into your direction, hinting that the plans are starting to become less credible on nuclear over time. So I think we will find that we'll need to replace nuclear with alternatives over time, indeed.
Just to mention also that the online tool allows you to test scenarios where the phase out of the nuclear is different compared to these chosen scenarios.
Okay, thank you very much. And in the meantime, we have our first question from the participants, and I would like to give the floor to Anna. You should be able to unmute yourself. Yeah, okay, perfect.
Hi, hello there. Hi, this is Anna Gumba. I'm a journalist with Climate Policy Media Carbon Pulse. And I just had a question about the road transportation and building scenarios specifically. Because one of the proposals that the European Commission is considering is to either to expand the EU emissions trading system to include those two sectors or establish some kind of carbon pricing in there. So I just wondered whether the modeling has considered this kind of instruments and whether they would be capable of delivering emission reductions by itself. Thank you.
Thank you for the question. So our approach doesn't include the policy chosen. So we're looking really at the technical side of things and implementing that through the model. So you'll be able to test that, and the underlying policy is not implemented. But if you look at the report we've done comparing our work with the impact assessments, we've worked with Ecologic as well, and they've looked and they've analyzed some of the questions you mentioned there. And our conclusion is that we need to be very careful, particularly in the choices we make in terms of policies, and certainly to include all of the sectors in the same trading system would be extremely dangerous. But even in terms of the mix of policy that you choose, certainly you won't reach the same impact with a carbon price compared to an ETS. And the Commission has also looked into these differences with their 3 scenarios, which we find quite interesting.
Okay, thank you very much for the answer. I think this was pretty clear. But if there is still an open question, Anna, please come in again. And is there anyone else who wants to take the floor?
And while we're waiting, I just wanted to add, we've really, created contrasted scenarios, and we strongly believe that both of them would be hard to reach, and that they're both interesting to look into, and that we have to find ways to combine them. So there's no one solution that will lead us to 55 or 65. It's just about bringing all of the solutions we have and implementing them.
Thank you. So maybe I will then raise a question, which came up to us when we used the tool. So maybe the question is, what is the main risk in terms of policy planning and modeling that you see in the approach of the European Commission to include LULUCF in their strategy?
Okay, so first of all, the very first risk is the confusion that you may have between the different targets. Okay, you know that in the debate, people are sometimes talking about LULUCF included or excluded. That doesn't help. So I think this is the motivation of the Commission to now harmonize with the UNFCCC and the Paris Agreement scope of emission, to have one clear objective, which is in line with the scope of the 2050 target. Now, having said that, many people fear that by including the LULUCF, we would actually lower the effort in the other sectors to and rely more on the forest to capture carbon. It's true that a 55% scenario, including LULUCF, that the scenarios from the Commission, at least, are actually scenarios of reaching almost 53% reduction by 2030. So they're slightly less ambitious compared to the scenarios we have been presenting here. Our scenarios reaching 55%, when you include the LULUCF, are actually going beyond the 60% because we expand the forest already well before 2030, thanks to the changes in the agricultural production. So there is a question of scope, there is a question of ambition, but the ambition in the different sectors will also be framed by the policies put in place. If you set up a carbon pricing mechanism combined with the effort sharing and so on, you may have some guarantees on the effort, the reduction of the emissions in the other sectors, and the LULUCF and agriculture have their specific policies as well in the end. So there are a few risks, but in the end, it's good, I think, that we have a harmonized scope to reduce the confusion. But let's be clear that the policies need to incentivize all the sectors to take action before 2030. Otherwise, we won't get there.
Yeah, thank you very much. And in the meantime, Klaus from CAN Europe has an additional question on that issue. So 60% inclusive LULUCF for the 55 scenario, and how much would be the net target for the 65 scenario?
I don't know it by heart, and I should check on the website. When you connect, you will see what it means, including the LULUCF. But let's be clear. Sorry?
It gets to above 70. So the scenario 65 that we have, which excludes LULUCF, then gets to 74 with LULUCF included. But remember that this is with a large ambition on the AFOLU sectors. But it's
exactly. So 70% is only possible when you start modifying the diets, rethinking the land use with the climate as a priority, and well before 2030, so that you can expand the forest by almost 50% increase of the forest area by 2030, which gives you a very large carbon sink by then. So and there are options of course to delay a little bit that transition, and this is very specific because you need also policies supporting farmers to shift fundamentally in their job towards more soil carbon management and towards maybe forestry also, which may take time.
And maybe to complement your previous answer, Jérôme, on the risks, I think one of the risks that I see by mixing and including LULUCF is that we need to ensure that the key is to reduce the emissions, right? That's the first thing we need to do, because those are emissions that will stay. And it's a very different nature to be capturing carbon in forests, which can also be implemented over time after 2030, than to really ensure that the capital investments are done right in all of the energy consuming sectors. Those are the sectors where you can have lock-ins that happen over time, and those are the ones where for example, the depth of renovation needs to be set right from the start and so on. If you don't do those things right in the energy sectors, you will not be able to get to a good position in 2050. While LULUCF is of a different nature, it's about capturing CO2, and so that's a bit of a risk of mixing the two.
Okay, thank you very much. When I was playing with the different options in my model, it was also really, it was really much of a difference between of 8%, so between 57% without LULUCF and 65%. So I choose very little biofuels and only a small change in diet. So it was very extreme. So if you compare both scenarios. So that's really insightful. And in the meantime, I saw that Jutta raised her.
I wanted to come in very, very briefly on the LULUCF issue. First of all, I find it remarkable that the European Union, who at the climate conferences, the COPs, always had opted for excluding LULUCF from the emission reduction goals, because it is highly variable and highly, well, it's not very valid data, so to speak. And in order to alleviate the possibility that countries do some calculation exercises in order to paint themselves as climate champions just because they have some forests, so to speak. The EU had always opted for counting emission reductions only and not the natural carbon sinks to be calculated in the same manner. But my concern is actually much different, because this summer when we drove around Germany in our camping car, every single forest I saw had dead trees by the hectare. It was really frightening. And so I think it is a bit risky counting on forests remaining carbon sinks and even becoming better carbon sinks in the next decades, because at least in Central Europe, the managed forests where we have a lot of spruce and other woods that don't really belong here, they will have large difficulties in the ever drier and hotter summers to simply survive, let alone store more carbon. So that's, in my view, the most risky bet in this scenario. Thanks.
You're right on that point. So we took a conservative approach to say that the amount of carbon captured by a hectare of forest is stable by 2050, even though in some scenarios you may see that some people expect that it will increase thanks to different types. But still, you're right. Forests are at stress today. It is dramatic stress for most of the forest, and so this is a key aspect. Our model here, this model doesn't include the impact of climate change on these natural sinks. We have other models for that, but this is not the case in this scenario. You're right to raise this point.
Perfect. So then I would like to encourage all of you, if there are questions, to raise them now.
If no one volunteers, I would just like to have another question. Actually,
Yeah.
in the transport sector, you had the energy demand decreasing. Of course, we will have less cars, no doubt about that. But by sharing those less cars, we will not necessarily have proportionally the less amount of kilometers. So is the energy savings that you see in the transport sector mainly due to the efficiency that which you of course have when driving electrically as compared to the internal combustion engine?
Of course, that's taken into account. That it's really, there's an amount of kilometers asked per passenger. There's an amount of passengers, and then you have the total amount of requested passenger kilometers. So that's fully incorporated in the model. We're not making vehicles drive less, but there's more people in those cars, and
Okay.
they're sharing the cars more.
Okay, thanks.
Okay. I think your tool is already really powerful, and I think it really helps to understand what needs to be changed. And if we are ending in the discussion how to implement the new climate goals, I think this will be very helpful to show that there are ways, and obviously there needs to be a political, there are sectors where it's maybe easier to progress than others. So, but as each model can be improved over time, do you already have plans to improve the model, or do you think there are still some inherent weaknesses which should be highlighted, or are you already completely confident with it, with this tool as it is? And again, it is already really impressive what one can model using this tool. Yeah, but maybe there are plans you would like to share with us how to even make this tool better.
Well, I'll give you a few elements of the things that we have on the roadmap. We're indeed developing the model further and trying to make it even stronger to ensure that we answer the questions, yeah, even with more depth. I think the very first thing we're doing is to ensure that we have member state granularity. So this model that you see here is built at the European level. We've done work for the European Commission through a Horizon 2020 project, which is called the European Calculator. So if you haven't heard of that, it's effectively doing a very similar approach. It's a simulation tool that leverages these 4 ambition levels for the levers, but it's really doing that at a much higher granularity with the member states included and connections between Europe and the member states and so on. So that's the very first thing. We're in the context of that project, we've improved also the modeling on basically all of the sectors. It was a 3-year effort, including a consortium of 15 organizations, including PIC and the Imperial College London and so on. So it was a very big effort to ensure that we had some more granularity and depth in the sectors. So now we're basically continuing to leverage that model. And the second thing I would say that we're trying to do is to ensure that it's even more user-friendly, to compare scenarios, for example, to see in more detail the assumptions and understand where they're coming from, having pop-ups of the 4 levels of ambition and descriptions of where they're coming from and so on. So that's another one. Jérôme, I don't know if you have thoughts on your sectors where the roadmap.
Obviously, there are many things that we could do to further improve it. On the agriculture, we are currently working on improving the agroforestry modeling to stick to new types of practices, which have a massive impact also and massive implications also on the different sectors. This is just another example, but feel free to send us feedback. We would love to get your suggestions on the potential improvements. But it's already really exciting for us also to hear that you have been using that tool. Our goal is to make it available, useful, and understandable. Now your job is to use it and to take the right decisions.
Maybe I'll mention another one, which is key. It's you've seen here how strong the connection is between the demand side sectors towards industry, and that's something that we haven't seen in many models. To be honest, it's quite a strong feature that really captures the circular economy. What we've done for the Flemish administration, the innovation department of the Flemish administration, is to take that even a step further and improve the connections between the industries themselves. So having some of the streams coming from the chemical sector going to another sector, or from the steel sector to the chemical sector. So really not only looking at all of the products required from the demand sectors and how they convert to materials, but also having more of that circular economy dimension between the industries themselves. And you start seeing that more and more in Europe. There's some industrial parks like that in Denmark that really bring industries together, already having thoughts previously how they could connect to each other. And so we're trying to capture that now.
Maybe to mention also that we have some more user-friendly versions of such tool directed to schools, for instance, or kids, to make sure that we can have the largest debate possible about what it means to reduce the emissions. Sometimes it's very, very theoretical for everybody, and it's useful to discuss with stakeholders from the industry, from the civil society, and also with children or teachers. That's also one area of improvement and work.
Okay.
Yes, now I have another question. You always get to the next question when thinking about one question. How are you assessing methane emissions, or let's call it greenhouse gas emissions other than CO2? Are you checking methane emissions with the 20-year value or the 100-year value, and what rate of methane slippage are you using for example, gas infrastructure?
Yeah, that's a very good question. We are currently using the 100 years definition as in the inventories, the national inventories, but we are working on making it as an option to switch from 100 to other. And there are also some new metrics that are proposed in the scientific literature to take methane emissions into account. That has obviously an impact on the livestock sector. And so on. So that's also something we're working on. That's a very good question indeed.
Okay, thank you. So I'm taking a last look at the raised hands. There is none, and in the chat there was no indication of taking the floor, but I give you the last chance before we are starting to wrap up. If there are questions, to raise them now.
I hope that means the presentation was super clear and not that there was lack of interest.
It was, yeah. Okay, good. Then I would like to ask Jutta to maybe find a few final words, or should I say? I don't know what our plan was. But there is one last question by Katharina. So I think we should use we still have a few minutes left. So Katharina, please go ahead.
Greetings to all. I have a quick question. So if anyone can answer me, I want to know, what happens first? Should we build infrastructure for electric cars, hydrogen cars, or do we push people to buy these cars? But who will buy a car if there's no infrastructure? And if you go maybe to Balkan, to your vacation, you're not sure whether you will have charging points. And even in Europe, there is a plan to build, I believe, 1 million of them in the next years, but it's still not stable to buy an electric car or hydrogen car. So what should be first? Should we push people to buy these cars and wait for infrastructure, or should the investment go into infrastructure first?
Thanks.
Well, actually, I have a very clear opinion on that. In my view, we should use taxpayers' money to support infrastructure only and not give premiums for buying electric. We should rather force, like China has done, the automotive companies to have a certain share of electric vehicles in the fleet that they actually sell on the market. That's the way how China achieved a very good increase of their electromobility. But of course, we need public support for charging, because these charging stations are relatively expensive, and it takes quite a long time until you really get a return on investment. So this is really difficult. I mean, I've been driving an electric car now for 3.5 years. I've never had difficulties charging, although in Germany the infrastructure is not optimal, I'd call it. But you always have the possibility. I have a so-called mobile charging station, because the car wants to speak with the charging station. And if you only have a dumb electric charger, like you have it in a household, that won't talk. So I have this mobile charging station, and then I can charge anywhere. It just takes much longer than having a real 11 kW or how much ever charging station. But you're right, we need the infrastructure for that. And I think there are some good examples already in the European Union where member states have said, okay, we'll roll out this infrastructure in order to make this possible. And also outside the European Union, if I look to Norway, where they have this very low level possibility of charging just at the street lantern. It takes all night, but usually I sleep at night, so usually I don't need to use the car all night. So I think, yes, we must roll out the infrastructure quickly, and we must impose quotas on the car manufacturers.
Yeah, I was going to not be as complete as you were, but say the same thing. We need to do both at the same time, and certainly improve infrastructure, but also there are used applications of cars that don't require to travel such a high distance. So there's certainly a need to ensure that we buy cars for those applications in the cities and for smaller distances, because that will help them drive the cost down of the cars. And so the reduced battery costs and their improvements will make it easier to drive longer distances. So it's really a positive reinforcement cycle that also needs to start with buying cars that can be used for shorter distances.
And remember, one of the key messages of our presentation, that electrifying the transport should also go hand in hand with decarbonizing the power sector if we want to reduce the overall emissions, as everybody knows.
Yeah, this is absolutely clear that we need green energy for the transformation. So that's absolutely clear. So driving an electric car with only energy produced by coal is very useless. But except from the driving experience, which is of course awesome in an electric car. So I think that of course it must be our top priority to invest in the infrastructure. But given the fact that electric cars, especially a little bit higher than the entry level, are compared to combustion engines still quite expensive, in the beginning, it could be helpful to have some incentives for citizens to invest in such a technology. So yeah, this was our last question. And now I think we can start wrapping up the session. And Jutta, would you like to go first?
Go ahead, team.
Okay, good. Then very quickly. So a few thoughts regarding the liquid biofuels. I think we will have to critically assess the upcoming refuel strategy of the European Commission, and also in terms of gas demand, we have to see how this matches the upcoming infrastructure plans and the reform of the 10E. Unfortunately, there have been a few votes during this mandate already where a slim majority was in favor of gas. So this is definitely a point we have to discuss, and we have to develop strategies on to overcome this, because I really share your concerns that this may be stranded investments, and this may indeed be negatively impacting the transition to real climate neutral energy production in the European Union. But first things first. So next week there's the vote on the climate law on the agenda, and we will definitely have to fend off groups that want to weaken the target by, for example, including international offsets as one of the very strong instruments. And this is a little more sneaky than just reducing the target, and we will definitely see those amendments. So next week is very decisive, and I'm looking forward to this. And once again, thank you for this very powerful tool.
Yes, thank you also from my side. I've learned a lot, and I will surely play around a bit with that tool. I think that we could be even more ambitious when it comes to reduction of meat consumption, because what we are seeing now is that the big companies start to offer actually vegetarian or vegan food and also meat alternatives, and some of which I have tasted are for me not distinguishable from meat, and I really love meat, I have to admit. So once a week I go to the market and I buy my meat from the farmer I know, and I know where his animals are out on the pasture. So that's something different, I guess, from a huge stable with thousands of animals. So I think in that respect, the message should not be stop eating meat, but stop eating unnecessary meat, because if you buy very inexpensive meat, it's totally clear that these animals have not had a life that could be called such, and that also the workers in the respective meat factories are not having a suitable job, but that they are living at a very low level of own self-subsistence. So if we manage to have a change of mindset there, I think we could even have a higher target of less meat consumption. I remember my great-grandmother, who was born 1897, and she used to tell me, well, you know, we were rich people. We could afford meat on Sundays. And that was something very, very normal 100 years ago. I don't think that we should go back to the lifestyle 100 years ago, but we should make ourselves clear that our lifestyle is not the normal and is not something that the planet can support. Not even if only we are living like that, let alone all other people in Africa and Asia and Latin America who live at a much lower level of comfort, of security, of I don't know, clean water, warm houses, whatever. So I think we should start behaving as species and not longer as individuals. And for this, I am pretty confident that we can achieve having a different mindset. And I'm incredibly thankful to Fridays for Future, who took to the streets, and what is even more important, they took to the breakfast tables, and they kept asking their parents, listen, why aren't we doing anything about climate change? And I think these kids have moved more than a lot of us politicians in the last decades. And I'm truly thankful for that. And I'm very happy that we have such a wonderful tool for everyone to play around. How could we actually achieve the emission reduction that we urgently need in order to keep this planet habitable for us humans? Thank you everyone for tuning in. As said, this webinar was recorded, so you will be able to re-watch it. And also Timo has posted the link to the tool in the chat, and Jerome has the link to the report of the on the impact assessment of the Commission, because we still also have to convince the Commission that Europe can be more ambitious. So to everyone, a very nice weekend. Thank you very much to our wonderful guests for being with us and being so patient with all these nagging questions. And see you next week, Timo. And I guess we will have some more talks with colleagues who are not yet convinced about the necessary goals for EU climate action.
Thank you very much.
Thank you very much.
Okay,
Thank you very much for this invitation.
Goodbye.
Bye, everybody.